Hello, everyone. Happy to see you here. My name is Vadim, and today I'm going to tell you how to build AI agents in Kotlin. But why? Why AI agents? The answer might look very simple, because this year is the year of Agentic AI. If you haven't yet, please check the news. McKinsey, Forbes, Morgan Stanley, all of them say about AI agents and how important they are in the model reality. Or if you open Y Combinator YouTube channel, most of the videos that you will find will be about AI. And they openly speak about how many AI startups they invested in the last year. What does it mean for everyone, for all of us? This means that tomorrow, or like the next year, we're going to see a lot of strong competition powered by all these AI startups almost in every single domain. And that's great. So is it just another hype? Or at least, is there something that I, as a developer, can benefit from? So let's check. So actually, I would assume that most of you here are engineers. And your main focus, your main job, has been always building your software, which is cool. At the same time, some other companies, such as Google, Anthropic, OpenAI, and many others, have been focusing on building AI. But let's now just put the user on the picture. Let's take a look at this thing from the user's perspective. Users would use AI to ask, like, how to solve the problem, how to do something. And then they will use your software to solve the problem. But that picture is actually a little bit outdated. So let's imagine the picture of the future. Let's imagine there is some helper robot in the middle, and the user will just ask the robot, do the whole work for me. And now it's the robot's responsibility to use AI and to use your software to solve the problem, and once ready, it will come back to the user with a ready solution. That looks very cool and promising, but then there is a real question. Who will be building these helper robots? What do you think? Actually, all of us will be building these helper robots. So again, what will change? Let's take a look at this classical, banking application example. You see this, checking, savings, credit cards, transactions, many other different things. But actually, what user wants, they want to solve the problem. For example, they can tell to the helper robot, show me my credit card, and it will do. So that's the idea. So AI has already changed the user experience of search, of text editing, of studying, and even of coding. That's JetBrains Journey, by the way. If you haven't tried it yet, please do it. I strongly recommend. So it can automate the coding tasks writing your IDE. That's the future. So the question is, will your application remain the same, or will it become agentic? Of course, the choice is yours. But first, let's understand what is AI agent and how to build one. So let me give you a very simple example. It's actually no magic here. You can do it by yourself, even right now. Just take your phone, open ChatGPT or any other AI chatbot that you use, and type the following. You can, it's a real experiment. You can do it by yourself right now. Just type, you're a banking assistant with the access to banking operations. And you can send money by writing only the following JSON, like name, send money, parameters, to whom, amount, and which amount. And it will understand. But now let's enhance this even more. Let's add some other operations, and also you can get the list of my contacts using another JSON, name, list contacts. You can do it by yourself. It's like a real chat. It's no magic, right? So, and I will, as a user, provide them in the format of another JSON. So I'm just communicating the language that I will use. So I will reply in the format of JSON, like name, name of contact, ID, ID of contact, and so on. And it says, got it. What's your problem? I'm going to solve it. And then I can continue this chat. I can say, send $100 to my wife. And it replies in the agreed format, in this JSON, like name, list contacts. And I also follow the agreement. I also reply in the JSON format, like name, wife, ID of my wife, name, Daniel, ID of Daniel, and many others. And it says, thanks, now I'm sending $100 to your wife. And it uses, again, the agreed JSON format, name, send money, parameters to exactly ID of my wife, amount, and exactly $100. So what we just did, we actually kind of solved the user problem with ChatGPT, but without any integration. It's just like a messaging history, right? But of course, like as an engineers, you can easily imagine how to integrate this into your app, into any app. You just need the right API for that, right? So let me just formalize a little bit. So we just learned the concept of AI tool. So what is AI tool? It's actually any function that the model can decide to call to solve the user problem. And now LLM in this system becomes the brain. Now it decides what to do, what tools to call, and when to call them, just to solve the user problem, for one simple reason, to solve the user problem. So, and this is actually AI agent. So again, it's a model using tools to solve the user's problem. That's a very simple definition. I'm going to refine it in the future, actually 2 times. But for now, let's stay with this one. It's going to be enough for our understanding. So, and now actually, I want to switch my whole presentation to the history of JetBrains. Well, you all know that JetBrains is responsible for creating multiple different IDEs, such as IntelliJ, PyCharm, and many others. But why? Why do we make IDEs? Not because we like IDEs, of course we do, but actually to make developers more productive. And we also actually made more other tools, like TeamCity on backend, to like many different things, also to make developers more productive. But do you know something is missing on this picture? Does anyone have any ideas what is missing here? We made something else very important, very cool. Actually, we made a programming language. We made Kotlin. But why? Because Kotlin makes all of you more productive. So we made Kotlin in 2016. That was like far away from now, right? So you may ask, what is JetBrains today? What is JetBrains doing today? And to answer this question, I would like to bring all of your attention to the center of the screen. And I mean to the very actual center of the screen. And you will see the answer. AI. During the last 2 years, JetBrains has been heavily focusing on AI. Some of you might have tried our various AI features in our products. Some of them were really successful. Some of them initially were not. And importantly, we as a company gained a lot of experience. You may have seen our AI assistants in IntelliJ and other IDEs. And some of you may even had a chance to try Journey, our full-fledged coding assistant, like coding agent that works right inside your IDE, and it helps you to automate your coding tasks. Moreover, we even train large language models from scratch. We made Melum. Currently, Melum is the best LLM model for code completion in its size category in the world. And we even trained Melum for Kotlin. It's like a separate model for Kotlin, and it's the best LLM model for Kotlin code completion in the world. Just think about that. So what else? Actually, what else would you ask? What else did we do with AI? Well, unfortunately, I'm not allowed to say more, but I will. More. Much more is coming. And of course, with all this experience, with all these things that we did around AI, we gained an understanding of what is AI agent, how to build AI agent. And of course, we are a big company. We're a very big company. And we have some requirements. We cannot afford doing toy experiment and small demos and these kind of playful things. We need to make real products and deliver them to real customers. And we need our agents to, first of all, to be predictable and also scalable and fast. Why? Because if something is slow, users are not happy. We are reading all of your reviews, and we are actually looking at many different charts and graphs, and we know that something is slow, users are unhappy. And what do we want? We want our users to be happy. You may wonder, like, why am I like telling you all of this JetBrains story? Because I strongly feel that you can easily project this to your own companies. Likely, you will see the same like requirements if you want to deliver something real, something with AI, into production scale. So let me continue. So other things. Also, we want our agents to be reusable. Why? Because like we have like different features, different product lines, different projects in JetBrains. And of course, if something is cool and it's working in one product, we don't want to replicate the job. We don't want to do the same job again. We want to easily like allow to reuse the same idea, the same agent in another product. And also, moreover, we want them to be composable. If some detail, some like small part is very cool and it's solving a great problem efficiently, we don't want again to replicate the job. We want to be able to like include it in many other different products and compose one inside each other. Also, of course, evaluation. Evaluation is very important. We need to be able to show our AI agent and other different AI things to our machine learning colleagues so that they can learn and know and analyze what's going wrong and how to fix that, to make it better, to make it the best user experience, to make them predictable. So, of course, we need our agent to be traceable for that. And also multi-platform. Because of multiple project thing, we are delivering for multiple environments. And of course, we need to be able to deliver agents to multi-platform. And last, but not least, of course, we need our agents to be in Kotlin. Why? Because we are the company that made Kotlin, and most of our engineers, they write in Kotlin. Of course, we are a very big company. We can easily like hire another machine learning department that will just solve all our AI problems, and they will write in different language. We can do that. But in my experience, that's not going to work. Why? You know this like very famous law. The way you like structure the team, structure the people in your organization, that will inevitably reflect the final product, the shape of the product, the level of integration. You know this like thing, like if you have like backend team, a front-end team separately, or if you have them together, that will actually impact the final product. And we want our AI agents, our AI functionality in general, to be tightly integrated inside our products. So that's the thing. Because why? We need to make the best user experience. That's the idea. And of course, with all these requirements in mind, we built AI agents framework that solves all of them. So meet Koog, Kotlin AI agent framework by JetBrains, based on our real AI experience. And today, it's getting open sourced. And you may wonder, why? Well, because we actually gained a lot of experience, we made a lot of mistakes, and we solved them. And we want to share this experience with everyone in the Kotlin community, so that everyone can benefit from that. And you can build your AI agents without having to learn from scratch. You can just reuse this. And then, eventually, I feel that you can also contribute to that with your AI experience. And all the Kotlin community can build this ecosystem around building AI in Kotlin. I really dream that at some point Kotlin might become the AI first language. So that's like the dream and the goal. Now let me just give you a brief list of features of Koog, not all of them. Of course, we integrate with most of large language models. We have MCP integration, embeddings, and a lot of pre-built components that solve existing problems, and many other things. But so far, I've been just talking, right? And you might want to, it's been 14 minutes. You might want to see some code. So let me show it. So this is a very simple thing. You can easily, with Koog, connect to any LLM, for example, OpenAI. Then with Kotlin DSL, you can construct a prompt, like system messages, user messages, some other messages. You can do that. And then you can ask the ChatGPT in this example to give you the next reply. That's cool, but that's not the real power. Because the real power lies in fully autonomous AI agents. And here it is. That's it. You just write this 1, 2, 3, 5 lines of code in your application, and immediately it just becomes agentic. You just write simple agent, connect to OpenAI, agent run, and any task. It will solve it for you. You don't need to write anything else. It just works. Do you believe me? Actually, you shouldn't. Of course, because how the model will understand what functionality from your application is available, you need to be a little bit of AI engineer. You need to just point that out. Like, for example, in this, we are building the banking application, right? So you have this send money somewhere in your app, and you just say, this is a tool, and it works. Do you believe me now? Well, actually, it's almost true already, but how would LLM understand, like, what is the meaning of each function? There is no magic. You have to be AI engineer, you have to explain. Just like write the descriptions, what is the meaning of each function, what is the meaning of each field. And now, this is the fully working example. That's it. You just register the tools from your application, provide them to agent, and run it with some user problem. Actually, that's it. That's very simple, yet very powerful, fully autonomous AI agent that will instantly make your application agentic. Nothing else is needed. So Koog, if you want, can be very simple. But Koog can be also smart. Of course, like, you can define very custom pipelines in the form of graphs. Like, just look at the left picture. You have like start, you ask LLM, then you call a tool, then you do something else, and then you finish. You can represent it in the form of a graph, which will like guide the LLM through the process. That's like the picture on the left. Actually, for you, it's on the right, but whatever. So, and on the other side, you will see the code. And just please raise your hand if you ever heard the term vibe coding. OK, a lot of people. And who heard the term vibe understanding? Actually, I just made it up. But for this presentation and for these like code examples, I just suggest like not diving too deeply into each line of code. But let's just like look at how beautiful it is. Like, it's just some Kotlin DSL. It's simple, and it allows you to like draw the picture with the code. So that's the idea. So you can just with Koog, you can define the nodes, like the steps of your pipeline in your agent, like ask LLM, call to, and so on, and then connect them with edges. And another beauty of this is that, first of all, it's like very composable. And second of this, well, if you show this code to your machine learning colleague that doesn't know Kotlin, they will be easily able to understand this and suggest improvements. And you can also design something very custom for your specific like banking application, for example. Like, you can say, like, you start, then you classify the request with AI, then you either solve the transfer money problem or you solve the transaction analysis problem, and then you finish. That's the pipeline, and you can describe that with code using Koog. So Koog can be very simple, and Koog can be smart. But most importantly, Koog solves real problems. Let me show you examples. First one is obvious. LLM is unpredictable and unreliable. Even if you open ChatGPT at the bottom, you will see this. You shouldn't rely on the LLM responses. And we know how to solve this problem. I will show later. Another problem. If you deliver something at production scale, not just your toy small application, but you deliver it to customers, you will see that inevitably the message history will grow. Whether it's a chatbot, like support assistant, or it's like something analyzing banking transactions. If you analyze a lot of data, the message history, all this tool calls, iteration, remember this ChatGPT example at the beginning? That's it. Like, you write the next message, you get the next response. Like, all of that, is the message history. It will grow. And LLM inevitably will be just lost in so much information. That's a problem. Another thing, calling tools in a loop is very inefficient in real life. Imagine that, remember again the same ChatGPT example. So LLM, you give the message, and you wait until it gives you the next prediction, the next action, the next tool call, for example, like send money. And then you wait again. You give a response, and you wait again. You get a response, and you wait again. That's very inefficient. And also, it costs you money. Like, you have to pay for the tokens again and again and again for each single tool call. That's a problem. And actually, we faced a lot more real-life problems when developing AI applications. And with Koog, you can actually cook the solutions. And I will show you how, but first we need a little bit of theory. So let me refine the definition first. So what is AI agent? Again, we told that it's a model using tools to solve the user problem. Then this is the agent, right? LLM call is an agent. So like your application calls the large language model, gets a response, and then makes some action. But it's not autonomous. The next level of autonomy is what Anthropic calls AI workflows. It's like a humanly designed logic, humanly designed pipeline. If you want an algorithm that uses application of yours and LLM one after each other to solve the problem. You can have like branches, different pipelines, and many different things. That's AI workflow. But it's kind of very predictable. You know approximately like what will follow after what. But that's not autonomous enough. So the real autonomous thing is the agent kind of thing. It's like this calling tools in a loop, where LLM becomes the brain. So in our understanding, and yeah, what's the beauty of it? It's like you don't know what will be next. You don't know when it stops. You don't know what tool it will call. So the combination of all of these different things is what we understand as AI agent. And now like, let me give you another definition. Agent strategy. Let me go back and forward, back and forward. You see the difference? So the strategy of agent is like the form, like the shape of your algorithm, the steps in the pipeline, plus how you work with LLM, but without your specific application logic. Why is it important? Remember, I told you that like we in JetBrains, we want agents to be reusable, composable, and many other things. So this actually allows you to abstract out specific use case of your application from the general strategy of the agent. And it allows to use this agent in different features and different products. So that's the idea of strategy. So, but why would I care, you would ask? So let me give you an example. So actually, this is a strategy. You have already seen this picture. It's this one, from Koog Can Be Smart. And you can express this strategy with Koog. But let's just like see how it works in real life. Imagine the user is asking this helper robot, send $20 to Daniel. So, and it will start working. It will start the strategy. Then it will ask the LLM what to do, because it doesn't know. LLM does. And it will get the first response, list contacts. And then it will use the API of your application to get the contacts and get the response in the form of like some data in your application. And then it will send the JSON to the LLM and wait for the next action. And LLM will say like, OK, send money. And we will use your application again to show the message to the user. Like this is the UI kind of thing that you can build on top of that, like how the user feels, how the user works with this agent. You can show the message. Do you confirm? Are you OK with this transaction? And the user says yes. And we say yes to LLM. We don't know what will be next. But this time, the LLM decides to stop. Why? Because the problem is solved. We say done. So if you look again at the strategy alone, without the example, you may notice that it's kind of generic, right? There is nothing about the banking application, nothing about anything else, just LLM, calls, responses, tools. So does it mean that it alone can solve any possible problem in the world? Well, let's think of this example. You give all of the banking application tools to the LLM, and even all the trading tools, and cryptocurrency tools. And the user would come and say, make me rich. Do you think that it's going to happen? Well, at least in the current state of technology, no. Why? Because LLM is unpredictable. So, imagine that, for example, like you are playing a hide-and-seek game with the blind LLM in this large audience room. It's quite a large room, right? Will the LLM be able to catch you if it's blind? I don't think so. It's going to be like spinning from one wall to another, back and forth, trying to find you, and it will fail. Because you give too much variety. And now let's think of another example. Like you build a thin corridor, and you just tell the LLM, just run forward, and you will find the target. I think that in this case, it will not have enough variety. It will just run forward and solve the problem. And that's actually where the development is needed. That brings us to the idea of making custom strategies, building the thin corridors for LLM to be predictable. Let me give you an example. You are preparing a quarterly financial report, and this could be your strategy. Like first, like you say, like you're collecting the data. This part of the strategy, you just tell to LLM, you are only collecting the data. You are not writing the whole report. You have very, very dedicated specific task. And you connect the LLM with only data collection tools, not all the tools. Then, with all the history and achievements of this step, you go to the next phase, to writing the report. And you connect the LLM only with writing report tools. And the task is also very specific here. And then, of course, that's a very responsible task. Like you're preparing financial report. You need to make sure that it's correct, right? And for this, we need to make sure that it passes compliance, for example. And you connect the LLM with compliance tools, and then somehow, like inside this strategy, you need to make sure, you need to force the LLM to follow specific steps. You need to make sure that it actually passes all the compliance. And then if not, if there are some problems, you go back to writing report, and you start it from scratch, or you add something to it, right? So that's the strategy. And with Koog, you can implement it. That's the whole code. So first, this is how you define the collection of data. You use just pre-built component. It's called subgraph with task. You give it a task. You give it a model. You give it tools. That's it. It's already implemented. You don't have to design it by yourself. Same thing with writing report. You give different task, different tools, different model, and it works. The next step is compliance check. I use different component here. It's called subgraph with verification. Why verification? Because I want to force the LLM to do the final check. I don't want it to finish beforehand. And then I also give the tools and the task. What's left? Well, you only just need to connect the three. Just glue them all together. And for this, I just connect the edges using code just to match the picture at the bottom. Very simple, and that's it. So that's cool, but same question again. What is AI agent? So this is actually I'm going to give you the final definition, what we understand, what is AI agent. So the agent is a combination of strategy, tools, connection with your application, and models. So that is AI agent. But we need to go deeper. Remember, I promised to solve a few problems. And one of them was LLM struggles with long context. Remember this picture? So again, let me repeat. LLM will read the whole history to make the next decision. It will lead to the problem that, for example, if the history is too long, it will be lost in the context, you will lose the accuracy of your solution, you will pay a lot of money because of the tokens, and you will also spend a lot of time waiting for the next response. And we made a solution. Very simple. You just use that component, you put it anywhere inside your strategy, and it works. So what it does, it will take the whole history and just change it to one simple message, like TLDR, what has been done. It will save you money, it will increase the accuracy in many cases, and also it will make it much faster. But do you see any problems now? Well, actually, this is the problem now. Instead of reading the whole book, LLM is left with just one sentence on the table. It doesn't know what to do, it doesn't have enough context. Of course, we also faced this problem while developing agents. And we also know how to solve it. We also built different strategies for history compression that you can use out of the box, or you can implement your own. For example, here, you can chunk the whole history in smaller pieces and compress each of them independently. And moreover, actually, if you know specifically what task you are solving, if you know specific domain that you're working with, you can provide specific facts that you need in the history. You can use the fact retrieval strategy. It's also there out of the box. You don't have to implement it. You just declare. For example, if I'm working with a banking application, and at some point for the next step of the strategy, I only need the risk factors and valuable purchases. The LLM will search for them and leave only them in the history. That's the idea. So this is basically the illustration how it works. Instead of the whole book, LLM will be left with only few important papers on the table. Next problem. I promised you to like solve the problem of calling tools one by one being slow. Again, let me illustrate this. Imagine you're building Android application of your bank with Kotlin, and you gave to LLM all the buttons as tools. So now the LLM will click buttons one by one to solve the user's problem. That's going to be very slow. Just trust me. You'll wait every next button click. You will wait for the LLM response. And again, you will pay for the tokens multiple times. And we have a solution. Just use streaming. So what's streaming? It will like stream like one response with multiple messages, multiple tool calls at once, and you don't have to read the whole. You can like start working already if you receive something. So how it works? First, you define the structure in Markdown. Like for example, here I'm defining the transactions, like recipient and amount. I'm defining it using the DSL from Koog in Markdown. And you may ask, why Markdown? Well, because we tested a lot of things, a lot of formats. And the Markdown comes out to be the most efficient for LLMs. Why? Because LLMs were trained to predict the next line, the next token in the text. And this is exactly how Markdown format is structured. Like to understand the next thing, you only need like a few lines above. You don't need the whole structure. That's why Markdown works the best. And we're providing the Markdown API out of the box. You can use it. And then, that's it. You can just call tools on the fly. You request the stream from the LLM, and then like when some part is parsed, you call the tool. Or you can even do it in parallel. Next thing, remember, evaluation is very important to like debug your agent, to understand how well it's working or why it's failing. You need to be able to trace, to like understand what happens after what. Like what LLM call is there? What is the response from LLM? What tool does it use? And why the tool response is misleading LLM and it follows the wrong path in the strategy. You need to debug this thing, right, as an engineer. And for that, you only do this. You install tracing, and you provide like the collector of the traces, like you provide where to store the traces. You can implement your own, or you can like use one of the available things. And of course, remember, we are the tooling company. And of course, soon we'll provide the IDE support for that. So you'll be able to visualize your strategy, what's happening right now in the agent, and you'll be able to also see the trace and debug the agent using your IDE. Next thing, last but not least, memory. You're probably like most of you are living in Europe, and you know that recycling is important. It's much better for the environment. And same thing with the agent executions. So if you have the agent that has successfully run and solved the user problem before, why would you run it again without any context? You can just save and like recycle the same information in the next run. And that's like the agent memory. So to use the memory, just install it to any agent and provide like where to store it, where to store the facts. And then you can design it as an engineer by yourself. You can say like, here, I want to save these facts in the memory. And later, I can load them and use. That's it. So actually, we have many more features. So if you want to learn more, visit our Koog hands-on session tomorrow. So to summarize, if you're writing in Kotlin, you're privileged to start building the AI future and to deliver it at production scale. And you don't need to have the expertise. You don't need to know how to cook AI, because with Koog, just take it and bake it. So actually, I've been talking for quite a while already, and sometimes people don't like me talking. So rather, let's maybe just go to GitHub and start building the AI future together. So thank you so much, and don't forget to vote. So actually, we have several more minutes. If you want to have a Q&A session, if you have any questions, feel free to come to the microphone here, and I'll be happy to answer them.
Hello, thank you for presentation. I have one question. What is the under hood of the history compress strategy? It's AI as well? We need to just double send, then compress AI, compress it, and return back, and every time we have to send it, right?
Yeah, thank you so much for your question. So yes, talking about the history compression. So actually, there are different strategies. And actually, there is also a strategy interface that you can implement by yourself. But the ones that we used, they actually use the LLM again to analyze the history. And you can actually use another LLM, which is not biased, and compress and like just give you like one fact or several facts or something like that. So that's the idea. So there is already a working and tested prompt inside, and specific logic to preserve like memory facts, store specific data, and form that to, like nicely so that the next time throughout the history, LLM will understand this context, like what to do with it. So does it answer your question?
I see two issues here is you have to pay again for the tokens, for the compression, and another, maybe it could be like a broken phone game that we send and get and lose something important in this context.
Yeah, thanks for the comment. So let me just show actually this slide again. So first of all, regarding paying for the tokens. Yes, sure. To make one single this LLM request, like to compress the history, of course, you will be paying for these tokens, but just once. Compare it with the fact that, for example, if you weren't compressing the history, you'll be paying it all one after each other, calling each tool. So it's like paying one time instead of paying like n times. And regarding the losing specific information, that's why that's the problem that we also faced, and that's why we made this strategy and this strategy. So you can point to LLM, and inside you can actually, it's open source, you can check the implementation. So inside like there is specific logic that makes sure that LLM retrieves these facts that are relevant and puts them specifically in the history so that this important information is not lost.
Yeah, okay, so I would like to ask a short question. It seems that you have a lot of experience with AI agents, and I'd like to ask, did you have any issues with security vulnerabilities? And if so, then how did you solve it?
Well, regarding security, it actually depends on how you apply the agent. So like you can have risk with security basically doing everything, like including like servers or even mobile. But in general, this is something that has to be more worked on the side of your legal team rather than on development side. So like if, for example, you have the right agreement and users understand and expect, they have the expectation, like what data goes where, then of course there should be no questions. And talking about like products of JetBrains, I cannot like answer for all the products, of course, but generally we don't store like any data. And we are also working on the AI enterprise project for enterprise customers. Like if you don't want to like send your data to like large language model somewhere, like you can connect to any other model, you can deploy it on premises, or you can use like local models such as Ollama. And in our framework, if you ask me, of course, we do support Ollama as well. So let me give you this slide one more time. So we support basically right now OpenAI, Anthropic, Google, Ollama, OpenRouter. And actually, there is just a simple interface that you can implement, and you can connect to any LLM. And also with OpenAI connector, you can use it with your own deployment of large language model that supports the OpenAI API. So you can deploy something on premises, and then nothing will exit the contour of your company. But in general, JetBrains is a company, we don't store anything, right? Any other questions?
Yeah. Hey, thanks for the presentation over here. You mentioned about optimizing calls to tools, and that you have used flows, for example, to deal with that. So in an application that uses voice for interacting with the user, where basically it's a bit unpredictable and it will result on calling external tools, what are your key takeaways on how we could optimize so that we don't make that much repeated calls to tools?
So if I got your question right, you're asking how to make sure that if you're using the voice recognition, you don't have to pay
exactly.
a lot for the tokens for the voice, or can you repeat again, please?
For the external tools. So you use your voice to ask something to the AI, and then that will result on calling tools to get other things or to do tasks. And what are your key takeaways on how we could optimize so that we reduce the number of calls to those tools? Because using voice is a bit unpredictable, so it.
Actually, in my understanding, I don't see really a big difference of user instructing the agent with voice or the user instructing the agent with text. So the only thing that you add to the system just by adding voice is this extra error probability that you may not understand the voice correctly. But that's more of something that you can delegate to the voice recognition tools and libraries. So
yeah,
actually,
I was talking a bit about. So you mentioned in your example, and it appeared that the example was fixed. So that code was fixed, and not, let's say, dynamic as a result of the voice command. So that's more there where I want to reach.
Actually, it's a great question. To be really honest with you, we didn't work that much with voice recognition. But we can actually discuss it on the booth.
Sure. Thanks for that.
Yeah, thanks.
Hello, over here.
Hi.
Thank you, Vadim. Great presentation. I had a question for the context that you're supplying the LLM for, each of those commands, each of these tools. It seems like a very similar problem to documentation, right? It's context that could already be in Swagger documentation or Java docs. Is there any good synergy that we could find to avoid this duplicate effort of communicating to my human clients and also to my LLM agents?
If I got your question correctly, you mean that to explain what is the meaning of each tool, you need to explain it with annotation, and your question is, can we use documentation for that, right?
Correct.
Yeah, that's actually an awesome question. We are actually experimenting on that right now. So we are experimenting on supporting of the kdocs in Kotlin, so that you can just use the kdoc and make a tool call from it, make a tool explanation for it for the LLM. But right now, there is no such thing, but we are actually considering that.
Okay, thank you very much.
Thanks.
Hi, thank you for the presentation. I have a question about, it's nice when you have a working agentic application, but building upon this, how do you test that there is no regression when you add features to your existing agent?
That's a actually very complex question, because for this, of course, you need many different components. One is obviously tracing. So I've already showed you can just install the tracing, save the traces somewhere, and then you have to make sure that they don't regress. And for that you have to build a lot of things. So we built actually an evaluation pipeline which runs on CI and evaluates the agent. And also, to remove this unpredictability kind of thing, we can cache the responses. And I think actually, even in the framework that we open sourced, you can see that there is a caching LLM provider. So you can cache, you can wrap any LLM provider, like OpenAI, for example, or any other, inside this one, and it will cache the responses so that whenever your tool replies the same result, it doesn't go back to LLM again if it has seen it before. if the response is already saved somewhere on the disk, like for your evaluation pipeline. It just takes the same response, and again, you can like take any trace, any like path of the LLM in the agent, and you can save it and reuse it for testing, so that you can make sure that you don't add another unpredictability in this pipeline, in this evaluation thing. And that allows us to actually catch the real regressions, but not some unpredictable LLM behaviors like today compared to yesterday. Does it answer your question?
But that basically mocking the response of tools, right?
We're not mocking the responses of tools. I mean, of course, you can also do that. Then it becomes more like of a test rather than evaluation thing. And of course, we actually have a testing API as well. You can mock LM responses, tools, save it on disk, and then reuse it. But for the evaluation, it's more complex thing. Like you have to make sure that whenever you change the action, change the agent, of course, some tool responses will be different the next time. But the ones that are not different will just take the existing response. We only test like the changing part, and make sure that, for example, on some benchmark, we are not losing. We are only gaining or staying on the same page. So that's the main idea.
Thank you.
Yeah. Other questions? No. OK. Yeah, then thank you so much again.